What is going on, Algebra Bros? It's Mr. C here, and in this video I'm going to show you how to solve the following rational equation relating to this example where Jim and Billy are cleaning a house. Alright, this example is an example for what's called a work problem, sometimes referred to as a constant rate job problem. Alright, let's dive right into it. So the first thing we're going to want to do is think of an expression that will cancel out all three of these denominators. And that expression is none other than the LCM. If I want to cancel the 4 out, I would need a 4. If I want to cancel the x out, I would need an x. And if I want to cancel out the x plus 1, I would need x plus 1. And what we'll do, since this is our official LCM, is put a copy of the LCM in front of each one of these fractions. So there's the LCM in front of 1 over x plus the LCM again in front of 1 over x plus 1 this time equals last copy of the LCM, in front of the fraction 1 over 4. Alright, now things are going to simplify. For instance, with the first cluster, we're going from left to right, the x's cancel, and you're going to be left over with 4 and x plus 1 getting multiplied to 1. Let's write that as 4 quantity x plus 1, okay, plus, looking at the second cluster, the x plus 1 part of the LCM cancels out this denominator, and you'll be left over with 4x times 1. Let's just write that as 4x equals, and on the right, just the 4's cancel out. So what's going to be left over is x and the expression x plus 1. Let's write that as x quantity x plus 1. Okay. So now what we want to do is clear parentheses. So we'll distribute the 4 to clear these out. That's going to be 4x plus 4 plus the second copy of 4x equals, and distributing on the right, we get x squared plus x. And lo and behold, we end up transforming from a rational equation to a quadratic equation. So my recommendation is to try your best to rewrite this equation in the format ax squared plus bx plus c equals 0, which is going to require combining a couple of terms on the left and bringing some stuff over to the right hand side. So let's take it one step at a time. So 4x plus 4x gives us 8x plus 4 on the left, equaling x squared plus x on the right. We'll subtract each of these over to the right hand side to get 0 equals x squared minus 7x minus 4. So there's our quadratic equation set equal to 0. And first attempt at solving for x would be to try and factor. You would be tasked with looking for factors of -4 that add up to -7, and we definitely don't have those factors. So the fallback plan would be to either complete the square or use the quadratic formula. I'll use the latter. So if we're going to use the quadratic formula, we got to identify our values of a, b, and c. Our value of a is the coefficient of x squared, so a equals 1. The coefficient of x is our value of b. Make sure to include the negative. And then our value of c is the constant term. Again, be sure to include the negative. So we'll plug these values into our quadratic formula. So that's going to be negative 7 plus or minus the square root of -7 squared minus 4 times 1 times -4 all over 2 times 1. So let's take care of the double negative with the first term in the numerator here to get us going with the simplification process. So that's going to turn into positive 7. And what you want to do is type the discriminant into a calculator, or you can work out by hand. Either way, you want to simplify the inside of the radical, also known as the radicand. If we do it by hand, that's going to be 49 plus 16. So what we're looking at there is 65. And this is all over 2. So there are two answers for x here, and I'm going to write them out in the following format. One potential answer for x is 7 plus the square root of 65 all over 2. Or another answer for x, potentially I should say, would be 7 minus the square root of 65 all over 2. Now, since this is an application type setting, I would recommend going from the exact value of these x's to a rounded value, just to give some more sensible numbers. But when you do that, you got to be careful with how you type these into the graphing calculator, or scientific calculator for that matter. Since the numerator has 2 terms, I would recommend including a set of parentheses around the numerator when typing this into a calculator. So I'm going to show you how to type these into the graphing calculator. And it looks like I'll have to do that in a follow-up video, which is no sweat for me. But with the first value of x, let me tell you what the approximate value for x is going to be. So 7 plus the square root of 65 all over 2. So with the first value of x, we're looking at approximately 7.5. And keep in mind that these are time values, and in this problem, time is given in terms of hours. So, you know, as it relates to the application problem, 7.5 stands for 7.5 hours. Now, as for the second value of x, this is approximately negative 0.5 hours, which, of course, negative time doesn't have any meaning. So I'm going to cross this out and just say that it's NA. Now let's be sure we understand what is our official answer to this problem. And it's kind of buried in this last sentence. It says, find how long it takes the son to clean a lawn. Okay, keep in mind that Billy is the son, and his time is based on his dad Jim's time. Namely, we have to add an hour to Jim's time in order to get Billy's time. So far we just have x, and x is 7.5 hours, meaning that for Billy, his time is going to be 7.5 plus 1, which is 8.5 hours. So that's officially how long it would take Billy to clean the house should he be working alone. Alright folks, that's it for this video. I will send out another one, in which case I show you how you can type those values of x into the graphing calculator. And if you have any questions on either of those videos, feel free to let me know. Otherwise, thanks for watching.